Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 6, Notes 3. So we're going to be talking about exponential decay. So yesterday we talked about exponential growth. When we talked about things were going up, they were growing, they were getting bigger. Well, today we're going to talk about exponential decay, which means they're going down, they're getting smaller, they're decreasing. So our exponential function graphs are going to be going down. So that's the difference between today and yesterday. So let's go ahead and let's take a look at this first one. Exponential decay is going to take the form of y is equal to c times 1 minus r raised to the t power. C is going to represent the initial amount, how much we started with. And just like yesterday, r is going to represent our rate of change, not as a percent, but as a decimal. And t is going to represent our time. So our c value is still the y-intercept. The only difference between this note sheet today and the one you previously did is the plus versus the minus. So today we're subtracting the rate instead of adding it, and that's what's going to make it go down. Alright, so let's take a look at this equation. So c is equal to 16. So I'm going to set up a preliminary equation here. So I have y is equal to 16 times 1 minus 0.45 raised to the t power, or the x power because we're graphing, sorry. So that's going to be raised to the x power. Okay, so then we want to actually subtract that out. So when you do that, you get 0.55. So I get y is equal to 16 times 0.55 raised to the t or x power. Keep doing that. It should be to the x power when we graph it. So let's go ahead and let's do our values. We have 0, 1, 2, 3, and 4. So those are the values that I usually go to. You could pick others if you want. Those are the ones that I like to do. So then what we're going to do is we are going to plug in our exponent. So we have 16 times 0.55. I'm going to start by raising it to the 0 power, which is really just going to be 16 times 1. So my 0 is going to be 16. Then we're going to take 0.55 and we're going to raise it to the first power. Well, when we raise it to the first power, that's 16 times 0.55, and that's going to give you 8.8. Again, it helps if you calculate this along with me to make sure you're on the right track. And then we're going to take it to the second power, and we get 4.84. And then we're going to take it to the third power, and we get 2.66. And then we're going to take it to the fourth power, and we get 1.46. So let's go ahead and let's graph that. So we're going over 0 and we're going all the way up to 16. That's the point that we're starting at. Then when we go over 2, we're only going up 8.8. So that's almost to 9. Then when we go over 2, we're going 4.84. So that's almost to 5. And then when we go over 3, we're going up 2.66. So that's just over halfway to 3. And then when we go over 4, we're going 1.46. So that's almost 1.5. So there I have my graph started there. So all I'm going to do is connect the dots. Now here's a really big thing about exponential decay. You have to be really careful down at the x-axis here. Remember that your graph is not crossing the x-axis. It's just going to come down and it's going to sit on top of it. It's not going to actually cross it. Okay? Next, let's take a look at number 2. So for number 2, we have a rate of 1/3, which 1/3, remember, is the same as 0.33. So let's write out our starting equation. So we have y is equal to 15 times 1 minus 0.33 raised to the x, I did t again, power, okay? Raised to the x power. So what we want to do is we want to subtract this out. Well, that's going to give us 0.67. So I get 15 times 0.67 to the x power, and y is equal to that. So that's my equation that I'm setting up that I need to graph here. So what I need to do is I need to plug in my values, 0, 1, 2, 3, and 4. So what I need to do now is I need to go ahead and plug in my exponents. So what I'm going to do is I'm going to plug in first, I'm going to plug in 0 for that exponent right there. And then I get 15. Plug in 1, I get 10. Again, hopefully you're doing this with me so you make sure you're plugging it in correctly. Then I get 6.73. Then I get 4.5. And then I get 3.02. So let's go ahead and let's graph these points. So we're going over 0, up 15, and that's going to cross at this point right here. Over 2, up 10, that's right here. Or over 1, up 10, sorry. Over 2, up 6.73. So that's almost all the way to 7. And then we're going over 3 up 4.5, and that's going to be here. And then over 4 up 3.02. That's going to be that point right there. So we're decaying on downward. But again, we're never going to cross that x-axis. So please make sure you kind of come down and you ride alongside it, but you don't actually cross it. Okay? Next, let's take a look at number 3. So for number 3, it says a fully inflated raft loses 6.6% of its air. Well, whenever I see a percent, I like to immediately convert it into a decimal. The raft originally contains 4,500. Here, remember, it says that the raft loses. So that's, we know, okay, we have to use exponential decay because we're talking about going down. It says it originally has 4,500 cubic inches of air. So write an equation for that decay. So we're starting with 4,500 cubic inches of air. And then we're losing, so I'm going to use decay. So 1 minus 0.066 to the t power, because we right now don't know how much time is passing. We're just writing our equation. So now to actually write the equation, I'm going to subtract that out, because that's pretty easy to subtract, and I don't have to worry about rounding anything. So I get 4,500, and then 1 minus 0.066, and when I subtract that, I end up getting 0.934, and that's going to be raised to the t power. So then what I want to do is I want to figure out what my t value is going to be, and that's going to be in part B. It asks us how much we're going to lose after 7 days. So what I'm going to do is I'm going to go ahead and I'm going to plug in 7 for t. So then I have 4,500 times 0.934, and that's going to be raised to the 7th power. So I can go ahead and I can plug this exactly into my calculators. So I plug it into my calculator and I get 2,790.23. Now when it's a decimal and we're not talking about a person, if we're talking about something that could have a decimal, I usually like to use 2 decimal points. And then we want to label it. So if we look back at the original problem, it's in cubic inches of air. So I need to make sure that I label all of my word problems. So this is going to be cubic inches for my final answer. All right, let's go ahead and let's take a look at number 4. So for number 4, what we want to do is we want to figure out the population. So it says right here that it's decreasing. Okay, that means it's going down. We need to use decay at an average rate of 0.3% per year. Don't get confused. Even though the percentage is a decimal, you still need to convert the percentage. So I have 0.3% that I need to convert into a decimal. So my rate is going to end up being 0.003. Okay, so now the starting population is 88,647. And then what we're going to do is we are going to subtract our rate. So we have 1 minus 0.003. And I can actually raise that to the t power because I know what t is. I need to figure out how many years passed between 2000 and 2013. Well, that's going to be 13. So I'm going to go ahead and I'm going to simplify this a little bit. So I get 88,647, and then in here I get 0.997 raised to the 13th power. Okay, so then when you type this into your calculators, you end up getting 85,251.3. And we kind of talked about this on the previous note sheet. When you are talking about a living person, you don't want to have 0.3 of a person, okay? That doesn't make sense. You want to look at your rounding. So because this is less than 5, we can just cut the number off and keep it the same. So that's going to be 85,251 people that are still living in Campbell County. Okay? Next, let's take a look at number 5. So for number 5, number 5 is not on there. Let's go back. Okay. So let's take a look at number 5. So you have to look at your notes here. It says, during an economic recession, a charitable organization found that donations dropped. Okay, if it's dropping, that means it's going down. So our rate is 1.1%, which means we need to move the decimal point over 1 place. So we get 0.011. So then when we get 0.011, we need to go ahead and that's our rate. Then it says that the current amount that they're getting is $390,000. So that's my starting value is $390,000. And then I'm losing 1.1% a year. So I'm going to go ahead and subtract off that decimal. Then it wants us to find the amount of donations after 5 years during the recession. So that's going to be my T, are those 5 years. So then I'm going to go ahead and I'm going to subtract those values. And when I do that, I end up getting 0.989 when I take 1 minus 0.011. And we're going to take that and we're going to raise it to the 5th power. So you can go ahead and you can punch this into your calculator. Now remember, when we're talking about money, we want to use 2 decimal points. We want to look at the 3rd decimal point when we try and figure out our rounding. So then when we do that, we end up getting $369,000 right there, and then we want to do 0.74 cents. And so I want you to plug that in your calculator and see what you get. Check that rounding. Make sure you're punching it in correctly. All right, so determine if the following is exponential growth or decay. Now here's how you determine if it's growth or decay. If it's growth, the thing that's being raised to the exponent is going to be greater than 1. So the thing being raised to the exponent is greater than 1. If it's decay, it's less than 1. So let's take a look at that first one. Is 7 greater than 1? Yes, so this one's going to be growth. Now on this one, the 2/5 is what's being raised to the x power. Is that greater than 1? No, so it's going to be decay. Okay, then taking a look at this one. Is this less than 1? Yes. That's going to be decay because it's less than 1. This one's going to be growth. And then I want you to go ahead and finish that last one up for me. Thanks for listening. Make sure you take your Schoology quiz once you're done.